Welcome to this episode of our podcast, where we dive into the fascinating world of home automation, specifically focusing on reverse engineering technology to bring more control to our living spaces. Today, we're going to dissect the story of someone who took a conventional home ventilation system and elevated it to new heights, integrating it with a platform called Home Assistant. Let's jump right in. Imagine you've just built your dream home, and it's filled with amazing technology. You have this cutting-edge duco-box Energy Comfort D325 ventilation system, which is engineered to keep the air in your home fresh by recycling outgoing air to preheat incoming air. Sounds great, right? But hold on. What if the control options are painfully basic, restricted to just a few modes and a simple button interface? Our protagonist in this story wanted more than just that. We start with the vision of wanting full control over air quality and energy usage, leading us to the root of this tale, the Duco connectivity board. This device promised a solution, but upon inspection, it turned out to be an ESP32 chip, a piece of hardware that sparked curiosity rather than satisfaction. So, what did our engineer do next? Well, they decided to dig deeper, beginning the journey of hardware reverse engineering. Picture this. Armed with a multimeter and a logic analyzer, they connected the dots using technical resources available on the Duco website, turning what could have been an overwhelming technical jungle into a carefully mapped out circuit. Now, here's where it gets really interesting. Relationships between different components and codes began to unfold. By analyzing how the device communicated, sending and receiving messages with specific byte patterns, they could crack the code, so to speak. They discovered a really cool header pattern in the communications. Those consistent bytes of 0xAA and 0x55 were like breadcrumbs leading them through the technical maze. It's almost like detective work, right? They initially suspected the protocol might resemble something established like Modbus, but a classic misdirection occurred. Instead, a unique communication system emerged. Each message contained distinctive identifiers that decorated the dialogue between boards and boxes, resulting in a pattern of requests and responses. But hang on, why would someone take the time to reverse engineer a control system, you might ask? For real-time responsiveness and functionality. Our engineer found they could not only change comfort settings, but could actually read the ventilation system's current mode, effectively becoming the master of the airflow in their home. Now let's imagine the moment our engineer decided to change the comfort temperature, shifting it from 24 to 24.5 degrees Celsius. What a satisfying thing to reflect on. They witnessed streams of data flow through their setup, confirming they were on the right track and hitting those expected values. And it didn't stop there. Soon, they ventured into deer territory, decoding CO2 sensor readings. A little hands-on experimentation, like breathing into the sensors, would show up real-time feedback on air quality. It must have been an absolute rush to see those numbers change. Well, through every twist and turn, our geeky protagonist turned this raw technological potential into something usable with Home Assistant. They crafted an ES Foam component, sharing it with the wider community by placing it on GitHub for all to benefit. Before we wrap up, let's reflect on the journey. Our guest showed us that technology is often a black box, but with curiosity and a willingness to dig deeper, we can transform it into something much more. What started as a limited control interface becomes a fully integrated system, allowing for better air quality and energy efficiency at home. So, what's the takeaway for our listeners? Don't accept limitations when it comes to your home technology. Be curious and dive deep.